So today we'll be speaking about limits. Now limits are the core of what happens of everything in calculus. Limits are like the building blocks. Well, functions are the building blocks. Limits are kind of like the pillars. Now, limits is like a fundamental concept in calculus. A limit is something which is used to express the behavior of a function. If this term is new to you, it's fine. I'll be explaining it in a bit. So, let's say we have a function where y equals f of x, and this is the graph of f of x. Now, what a limit effectively does is, say this is x equals 7 and this is y equals 4. What does this function approach as you get closer and closer to 7, as you really hone in? So, like, say this is obviously a cubic. Now, let's assume f of x equals x cubed minus 3x square plus 2, something like that. It's probably not it, but I just approximated it. I'm probably really off. So we'll be writing out the limit with this symbol lim. We take the variable x approaching, and in this case it's 7, so we write a 7 here, of the function. So of x cubed minus 3x square plus 2. So what this limit effectively says is what happens as you put in closer and closer values to 7 as possible. So first you can try like 6.9 cubed minus 3, 6.9 square plus 2, and then maybe you can try 6.9999. So you get the point. You get as close as possible to 7 as possible. Now, these functions where every value is real, every point on the function is defined, these are known as continuous functions. Now, these continuous functions are well behaved and they're pretty easy to work out the limits of. Now, looking at this limit example, you probably realize something. The limit of a function, let's assume it to be g of x to be different this time. So the limit of a function g of x as x approaches an integer a or any real number a will equal, if it's continuous, g of a, where a is the number, the real number which will substitute into the function. Now this is really important. And there are two more concepts to talk about with limits before we move on to the other types of limits. So this over here is known as an overall limit. That basically means an overall limit. So what the overall limit basically tells you is that when this function, the function g of x, approaches this value overall, it doesn't matter from where you're approaching it, it will just approach this value. But not all functions are like that. There are some functions, let's assume this to be h of x and this to be x, and this is what the function's like. Now obviously, if you were asked what the limit of this function would be, you wouldn't know. Like, is it this value, what is it? So this actually has two. The overall limit for this function doesn't exist because there's no single value, there's a jump. These are known as discontinuous functions. Now these discontinuous functions I'll be covering in a later video in more in-depth detail, but what is essentially required is that you take the limit from the left hand side and the right hand side. We'll be learning the notation for each of these in the next video, so yeah, stay tuned for fra guerrieri può far bacco, grande stacchi stretto sacco, schioppo in spalla.